So now what we want to do is prove for any string that is an even length palindrome, it's in the language. So we're going to do this by noting that any string that is an even length palindrome can be written of this form, where it's n many characters and then the same n many characters written backwards, right? So now we can do induction on n. So for the base case, where n is 0, that's going to be when the string is empty. And clearly the empty string has a derivation, as s has a production that goes straight to epsilon. So now for the step case, we'll assume for any string alpha of the form n characters forwards and the same n characters backwards, it has a derivation. And then we want to prove for any beta of the form n plus 1 characters forward and n plus 1 characters backwards, that it also has a derivation. Consider the case where b1 is 0. That means beta can be written as 0 on both sides, and then sandwiched in between is an even length palindrome of length 2n, that is n characters forward, n characters backwards. And this thing looks like an example of alpha from my inductive hypothesis. That means there exists a derivation for this string here in the middle, which means I can use this to obtain a derivation for the entire string, as s can go to 0s0, and then I can replace this s with this sequence of productions to get 0 alpha 0, which is the same thing as beta. And then for the case where b1 is equal to 1, you basically do the exact same argument again. And so that gives us that regardless of the value of b1, we can find a derivation from s of the string beta. Hence we've proven by induction that all even length palindromes really are produced by this grammar. They really do have a production from s.